Hello everyone. In this video, we are going to learn the pulley problems. This is your third video of Newton's laws of motion. So students, in this video, we are going to learn about free body diagram, FBD, free body diagram. Every object will consider as a free body and we will try to calculate the force acts on it, and from this we can solve any type of pulley problems and all. So students, in this video, please follow this video properly. If you follow properly, then from this video you can calculate the pulley problems within 10 to 15 seconds. Depends upon your calculation speed. So if you follow this video properly, then you can solve the pulley problems within 10 to 15 seconds for sure. So students, without wasting time, let's get started. Our first problem, this is the first pulley problem. It's a basic common pulley problem. See, here two masses m1 and m2. Suppose mass of m2 is greater than m1, so acceleration in this direction. And student, one more thing, suppose there is only single string. Single string means the tension T, same tension, T will act, same tension. So first of all, consider the m1 as a free body. So take it as a free body. Next, number of forces act on it. m1g downward, tension upward, acceleration direction A along this direction. So from this you can see the tension and m1g both are in opposite direction. So T1, direction of T1 is upward, acceleration is upward. So T1 greater than m1g, T1 greater than m1g, because acceleration upward, tension upward. So take m1 as a free body, and first of all you will write the equations of m1. So for m1 we can write T minus m1g is equal to m1a. This is your first equation. Students, listen here. Why T direction of T upward and acceleration upward, that's why T greater than m1g, that's why T minus m1g equal to m1. This is your first equation. And in second equation we take for m2. For m2 tension upward, m2g downward. So now you tell me which one is greater, m2g or tension? See, acceleration downward, so m2g greater than the tension. So you can write m2g minus tension equal to m2a, because m2g downward, acceleration also downward. So in second equation you can write m2g minus tension is equal to m2a. This is the two equation. If you solve these two equations, you will get T and acceleration A. So if you can remember it, so you can write A equal to, if you solve it, you will get m2 minus m1 by m1 plus m2 into g, and for tension 2 m1 m2 by m1 plus m2 into g. For computation, students, you have to remember these things. To if you put this value, you will get the result. Okay, understood? So students, but you can calculate the acceleration. Suppose they ask for acceleration, you can calculate the acceleration with the help of the tricks. Okay, tricks means within 10 to 15 seconds you can calculate it. How? See. So please pause the video and write it down. Okay. See students, think, this is a total, this is a system, and you just stretched it like this. So this is your pulley, and this is your m1, this is m2. I just open it like this. So m2g here m1g, and tension both sides cancel out, equal and opposite both sides cancel out. So acceleration direction, this direction, see, this is the acceleration, so this is the acceleration. So you can write acceleration in the direction of m2. So which one is greater, m2 or m1? Yes students, m2 greater, because direction of acceleration m2 same. So m2 greater than m1. So you can write the net force m2g minus m1g is equal to net force, means total mass into acceleration. So acceleration equal to m2g minus m1g by m1 plus m2. Just take g outside. So this is your result. Same result. So students, you can calculate the acceleration with the help of these tricks. If you know the value of m1, suppose here given 1 kg, here 2 kg, so put the value here 2, here 1, here 2, here 1, so g by 3. Done. So you need only 2 seconds. G by 3, G 10 by 3. So you need only 2 seconds to solve this Pulley problem. Okay. So go to the next problem. Please pause the video and copy. Next problem. See the next problem. Problem number 2. This is a problem number 2. Problem number 2. Write it down. Problem number 2. Try it yourself. I'll draw the problem number 3. You try it yourself. See students, in this case you can see m1 rest on a table and m2 lying outside the table, means it's hanging outside the table, m2. So you can draw the free body. You can see as m2 as a free body. First of all, you draw the tension. Tension always acts towards the point of suspension. Where the suspension? Here. So tension always acts towards the point of suspension. Take m2 as a free body. So the m2g downward, t upward, acceleration this. So for m2 you can write. You can tell me m2g. Which one is greater? Acceleration downward, m2g downward. So acceleration greater m2g. So you can write m2g minus tension is equal to m2a. Why? Because see, acceleration downward, m2g downward. Acceleration downward, m2g downward. Which one is greater? m2g greater. Which one is greater? m2g greater. So you will write first m2g minus tension equal to m2a. Understood? m2g minus t equal to m2a. This is equation number 1. For equation number 2, for m1, you can write for m1. For m1 rest on the table, there is a no m1g, only tension and acceleration direction this. So you can write tension equal to m1a. That's all. This is the 2 equation. If you solve it, you can get T and M. T and A. So now we apply the tricks. See, remove all these things. Take this a free body. Take this a whole as a system. So here is the M1. Here is your pulley, and this is M2, M2G here, and here is a tension. tension cancel out, resting on the table. So there is a no G, only single force M2G, only single force M2G in this direction. So you will write M2G is equal to the net force, means total mass M1 plus M2 into acceleration. So A equal to M2G by M1 plus M2. Now put the value 1, 2, you will get the answer. So you need only 5 seconds to solve this problem. But you cannot solve the tension, okay, with these tricks. You can solve acceleration, okay. So you can solve the acceleration within 5 seconds. Okay students, are you happy? Next, go for the third problem, problem number 3. You just pause the video and write it down. See, this is the third problem, our third problem, M1, M2 like this. So here is an inclined plane of defined inclination 30 degree and 60 degree. For M1 you can write, divide the mg like this. This is M1g. So this is your theta. Theta means 30 degree. So here we put theta 1, here I put theta 2. So this is theta, means here will be m1g cos theta, because theta, the angle between theta means cos theta, and here the component is m1g sine of theta, which is in this direction, acceleration in this direction, tension in this direction. Tension always acts towards the point of suspension. This is the point of suspension. The tension always acts towards the point of suspension. Now you tell me, for M1, for M1. See, acceleration direction, this direction, tension, or this direction. So you can write which one is greater, acceleration M1G or tension, M1G or tension, acceleration upward, M1G downward, tension upward. For M1, tension upward, acceleration upward. So tension minus M1G sine of theta is equal to M1A. Okay, this is equation number 1, and for equation number 2 for M2. Am I right? M2 similar. This is M2G sine theta. Similar way you can solve it. M2G sine theta in this direction, tension upward direction. So you can write M2G is greater than tension. So you can write M2G sine of theta minus tension equal to M2A. See students, in free body diagram we cannot consider the whole system. You only consider M1 as a free body, M2 as a free body, and write the equations and solve it. You will get the T and A. Now students, we will apply the tricks. Suppose in this case you can see tension cancel out, M1G minus M2G, and this is the total net force. So if you solve it, you can see tension cancel out. So M2G if greater, then M2G minus M1G sine of theta is equal to M1 plus M2 into A. So A equal to M2 sine of theta minus M1 theta 1 theta 2. Okay, this is theta 2, so it will be theta 2. Here is a theta 1, here is a theta 1, here is a theta 1. So M1G sine of theta 2 theta 1 G outside by M1 plus M2. See, only 2 or 3 seconds required to solve it. Okay, no need to calculate the calculations, simultaneous equations and all. You just put the value and done. See, here is the resultant force M2G, here M2G minus M1G. M2G minus M1G is equal to M2G minus M1G is equal to this M1 plus M2 into A. That's all. So this is all about the pulley problems like inclined plane and tabletop and tooth machine. And then your next problem, suppose 3 masses lie on a floor. So please stop the video and write it down. Problem number 4. Problem number 4. Suppose here's the floor and 3 masses, M1, M2, slightly less mass M2 and M3. Force act on it. This is applied force. Now you have to calculate. You need what? Tension and acceleration. See students, here is the two tension T1 and T2. Acceleration, suppose the force direction this, so acceleration must be equal to in this direction, acceleration. So student, now you tell me the 3 equations. First of all, you need to calculate the acceleration. So you know acceleration means force equal to total mass into acceleration. Total mass of what? M1 plus M2 plus M3 into acceleration. So acceleration equal to F by M1 plus M2 plus M3. Understood? Now, if force is given, then you can M1, M2, M3 given, then you can calculate the acceleration. Next, T1, T2. First of all, you want to find T2 because this is only single force T2 for M3. So you can write T2 equal to M3A, and for M1 this is for M3, and for M2 you tell me how will you write M2. See, M2 is a free body, here T2, here T1, acceleration here like this. So you can write which one is greater, T1 or T2? Yes, T1 students, T1, because acceleration in this direction. So you can write T1 minus T2 is equal to M2A. That's all. I think students you understood. Now if you put the value of T2 here, then we will get T1. Am I right? And acceleration you can find from the first equation. So you can solve this problem. Okay. Now copy it. Now students, problem number 5. Copy it. First draw it. See here M1, M2, M3, 3. Pause the video and draw it first. See students, here M1, M2, M3, 3 masses. attached with two string. First string tension T because single string single tension, single string single tension. In second there is also string where you can write T1, put T1. Now you can solve the problem with the help of FBD, free body diagram. How? First of all, you can tell me what is the equation for M1. Here M1G downward, acceleration suppose here. So here acceleration upward. So you can write acceleration upward, tension greater. So you can write T minus M1G equal to M1A. T minus M1G equal to M1. Am I right? This is number 1. Number 2 for M2. See here for M2. Here is the M2. M2 for M2. See here if you consider M2 as a free body. So M2G downward. T1 also downward, T upward, acceleration downward, acceleration downward. So its acceleration supports T1 and M2. Acceleration supports T1 and M2. So you can write T1 plus M2G. Am I right? Because both the direction downward and it supports the acceleration minus tension upward. Then you can write M2A. This is equation number 2. See students. Okay, just pause the video and think and then write. Then for M3 downward, here M3G, T1 upward, acceleration downward, so M3G minus T1 is equal to M3A. There is no other forces. So if you solve this equation number 3, so if you solve this 3 equation, you will get the answer. For T1, 3 equations, 3 unknown. T1, T, acceleration. These 3 quantities unknown. T1, T and acceleration. Understood? Copy it. See students, next problem. Problem number 6. First of all, you copy the problem. See, this is a 2m mass raised on a table and here is a pulley. So from this rope, actually it rotated from this pulley and it looks like this. Okay. So whenever the acceleration direction this means this m goes down, then the 2m move in this direction like this. I think you understood. See student, if m1 was down, then 2m go in this direction with the help of acceleration A like this. If you pulled it, then it will go in this direction. So first of all, you draw the tension. For drawing the tension, see first of all tension T. Here also tension T. Tension T. So in this case, tension will be 2T because T here T and here also T. It is a movable type pulley. So in movable pulley, T means total tension 2T. Student, when you will write 2T, the acceleration will be, if you write acceleration here 2A, think it's a 2A, then there will be A. Means, students, one more important thing, please listen, sum of tension into acceleration is equal to constant. So, if tension, sum of the tension into acceleration equal to constant. If tension is T, then acceleration will be 2A. If tension is T, then acceleration will be 2A. Think for M, T into 2A, and here also, if tension is 2T, then action will be A. So, in both cases, work done remains same because force into displacement, acceleration is nothing but a displacement with respect to second square. So, force into displacement means work done means energy always conserved. So, you can apply this thing. Okay, so if tension is 2T, then action will be A. If tension is T, then action will be 2A. Okay, now write the equations. For M, very easy. You know here mg downward, acceleration downward, which is 2A, and tension upward. So you can write mg, right student? Mg minus T is equal to ma. Ma means m into 2A. Am I right? M into 2A. M into 2A. Mg downward, tension upward, m into 2A. Am I right? Next is equation number 1. And for equation number 2, 2m. So for 2m, you tell me, for 2m, 2t, only tension 2t equal to 2m into A. 2m into a, because single acceleration. If you solve it, you have 2. If you solve this two equation, you will get t equal to and a equal to how much? Okay, copy. See students, next problem number 7. Here is an inclined plane attached with 1 kg body. Here is a 2 kg body attached with a mobile pulley. See, this is a mobile pulley. So in this problem we can solve the for mobile pulley problem. So in mobile pulley there is a tension T, single string, single tension. But in this case here you can write this is 2 kg. Here you can write 2t, T2t. Okay. Now you know if here the tension 2t, then acceleration, if the acceleration if this is the acceleration direction, then what time it will go rise? It goes rise. It will be a okay, a, and here the acceleration will be t means 2a, so that the tension and acceleration both are same. Now you know if there is a mg, so the downward force m1g sine of theta. Am I right? m1g sine of theta. We have already done m1g sine theta. So here theta means suppose 30 degree. Value, all the value given. So m1 means 1. So m1 means 1. G sine 30 means half. So here the force is g by 2. Acceleration 2a in this direction. So for 1 kg you can write tension upward, acceleration downward. So which one is greater? G by 2 is greater. So g by 2 minus tension is equal to 2a. Equation number 1. G by 2 minus tension equal to 2a. G by 2 minus tension equal to 2a. 2a downward direction. G by 2 downward direction. For second body 2 kg. Here 2g, mg, 2g. 2g downward, 2a upward, a upward. So you write 2t minus 2g is equal to 2a. So if you solve these two equations, 2g downward, a upward, 2t upward. So 2t greater, 2t minus 2g equal to 2a. So if you solve it, you can get a and t. Okay, copy this. Problem number 7. Next, problem number 8. Next students, I am coming with a very important problem. This is a very important and a very interesting pulley problem. There is a 3 masses m1, m2, m3. In this case, see students, you have to find out a1 and 2. The acceleration here, acceleration suppose a1, and here for this pulley a2. 2 pulley, 2 acceleration. Now this is a tension T, this is a tension T, and here is the tension will be 2T, T, 2T, okay? And if there is 2T, here also 2T. So students, now you can solve it by yourself, very easy. See here, if the pulley acceleration A2, then see here I will apply trick. See A1 downward, A2 here downward. So you can write for mass 3, here acceleration will be A1 minus plus A2. Okay, because this acceleration downward, this acceleration also downward. And you tell me for M2 you will write A1 minus A2. Okay, A1 minus A2, because A1 downward, A2 upward. For 2 pulley, A2 upward. Okay, so A2 upward, so A1 minus A2. That's all. We have done. Now you just write the equations. For 1, you know how to write for 1. For 1, here is 1g, mg, 1g, mg, 1g, m mass, g, 1g. So 1g downward, 2t upward, acceleration where? Upward. A1, the direction of A1 like this, so A1 upward. So we'll write 2t upward, 2t minus 1g equal to 1a. Equation number 1. 2t, a also upward, 2t minus 1g equal to 1a. Understood? Next students, For 2, this is for body 1. For body 2, acceleration here 2g, here is 3g, here is 2g downward, acceleration upward. So we'll write t first, t upward, t first. T minus 2g is equal to a1 minus this a1 minus a2 into 2 a1 a2. This is equation number 2. For equation number 3, 3g downward, 3g getter, so 3g minus t is equal to a1 plus a2 into 3. That's all. This is equation number 3. If you solve these 3 equations, you know the value, then you will get a1, a2 and a3. Students, this is all about Pulley problems and FBD. So students, in next video we will going to discuss about inertial frame of reference and non-inertial frame of reference. Okay students, so keep studying. Thank you very much.